Hi everyone, in this video we will learn about linear functions and graphs and equation of straight line.
Cartesian coordinate system. An xy-axis, also known as a Cartesian coordinate system or a coordinate plane, is a two-dimensional plane of points defined uniquely by a pair of coordinates. The rectangular coordinate system consists of two real number lines that intersect at right angles. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. These two number lines define a flat surface called the plane, and each point on this plane is associated with an ordered pair of real numbers x, y. The first number is called the x-coordinate, and the second number is called the y-coordinate. The intersection of the two axes is known as the origin, which corresponds to the point 0, 0. So remember, x, y. X-coordinate always comes first, followed by the y-coordinate. Some children may be taught to remember this with the phrase, along the corridor, up the stairs, meaning that they should follow the x-axis first, then the y. Here is the quadrant. The x and y axis breaks the plane into four regions called quadrants, named using Roman numerals 1, 2, 3, 4 as pictured. In quadrant 1, both coordinates are positive. In the quadrant 2, the x-coordinate is negative and the y-coordinate is positive. In quadrant 3, both coordinates are negative. In quadrant 4, the x-coordinate is positive and the y-coordinate is negative. Plotting points. Plot the ordered pair -3, 5 and determine the quadrant in which it lies. So when you are drawing in the millimeter graph paper, so draw the horizontal line. This is the x-axis. Remember, x-coordinate always comes first. Then this is the vertical line. This is the y-axis. Here is the origin, 0, 0. This is positive 1, 2, 3 for the x-axis. On the left side, this is -1, -2, -3. And then going up for the y, this is +1, +2, +3, +4, +5. Going down, this is -1, -2, -3. Then, where is -3, 5? Remember, x, this is y. So x is -3. And then, y is 5. So here is the point, -3, 5. So in which quadrant which it lies? So it's in quadrant 2. Remember, this is quadrant 1, quadrant 2, quadrant 3, and here is quadrant 4. Plot the set of points 5, 3, -3, 2, -2, -4, 4, -3, and indicate in which quadrant they lie. Remember, x-coordinate always comes first, followed by the y-coordinate. So 5, 3. 5, 3. Next, -3, 2. -2, -4. -3. 5, 3 is in quadrant 1. -3, 2 is in quadrant 2. -2, -4 is in quadrant 3. 4, -3 is in quadrant 4. Ordered pairs with 0. Ordered pairs with 0 as one of the coordinates do not lie in a quadrant. These points are on one axis or the other, or the point is the origin if both coordinates are 0. So for example, 0, 6. 0 is x, 6 is y. So here is the y-intercept. Means when x is 0, y is 6. Next, -4, 0. -4 is x, 0 is y. So over here, this is -4, 0. This is the x-intercept. Means when y is 0, so x is -4. Now here, plot the set of points A, 5, 0. Five is x, 0 is y. Next, point B, -5, 0. C, 0, 5. 0 is x, 5 is y. D, 0, -5. E, -10, 0. F, 10, 0. G, 0, -10. And the last, H, 0, 10. Plot this set of ordered pairs for 0, -6, 0, 0, 3, -2, 6, and -4, -6. So the scale indicated the x-axis may be different from the scale indicated on the y-axis. So choose a scale that is convenient for the given situation. So for example, the x, they are 4, -6, 0, -2, -4. For the y-axis, there are 0, 0, 3, 6, and -6. So for example, over here, this is x, and then here is y. Then I write over here, this is on the right side, this is 2, 4, 6. While on the left side, this is -2, -4, -6. So each tick mark on the x-axis represents 2 units. How about for the y-axis? I write over here, this is 3, 6, 9. Then below here, this is -3, -6, -9. So each tick mark on the y-axis will represent 3 units. So now here, this is for 0. Then -6, 0. And then 0, 3. -2, 6. And the last one is -4, -6. So I repeat, this is 40, 03, -26, -60, and here is -4, -6. Plot this set of ordered pairs, -6, -5, -3, -3, 0, -1, 3, 1, and 6, 3. Then, join the points in order with straight lines. In this example, the points appear to be collinear or lie on the same line. On a sheet of graph paper using a scale of 1 cm to represent 1 unit on x-axis and 1 cm to represent 1 unit on the y-axis. Plot the points P, 2, 5, Q, -2, 5, R, 4, -2, and S, -3, -5. So don't forget, in the graph, the x-axis is the horizontal line and the y-axis is the vertical one. So this is 1, 2, 3, 4, 5. And then here is -1, -2, -3. This is 1, 2, 3, 4, 5. And then over here, this is -1, -2, -3, -4, and -5. We usually identify points by capital letters. So P is 2, 5. P, 2, 5. And then Q is -2, 5. R, 4, -2. And then S, -3, -5. Shows the point 2, 4 and 3, 6 plotted on a graph paper using a scale of 2 cm to represent 1 unit on x-axis and 1 unit to represent 1 unit on the y-axis. So here is the x-axis. This is 1, 2, 3. Then here is the y-axis. This is 1, 2, 3, 4, 5, and 6. Two, 4 is here, and then the next is 3, 6. So the equation is y is equal to 2x. How to get the equation to x? y is equal to mx plus c. The gradient is 2. How to get 2? So over here, as you can see, one, 2, 3, 4, 5, 6 divided by 1, 2, 3. 6 divided by 3 is 2x, and then the y-intercept is 0. So 2x plus 0. So y is equal to 2x. On the set of coordinate axis, plot the points a to 3, b 0, 4, c negative 2, 3, d negative 1, negative 2, e negative 3, 0, f 2, negative 4. So don't forget, we usually identify points by capital letters. So here is a to 3, this is c 0, 4, this is c negative 2, 3, this is d negative 1, negative 2, this is e negative 3, 0, and this is f 2, negative 4. What is the ordered pair of A? This is x-axis, this is the y-axis, here is the origin, 0, 0. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. So A is 1, 3. In the previous section, we have learned how to use the coordinate xy to describe the position of a point in a plane. In this section, we will study the relationship between the two variables x and y. A function is a relationship between two variables x and y such that every input x produces exactly one output y. The input x and the output y of a function can be written as an ordered pair x, y. A function can be represented using words, an equation, a table of values, and a graph. So over here, y is equal to x plus 3. Y is the output, x is the input, and 3 is the rule. The equation of a function is y is equal to 2x minus 3. Find the value of y when x is 4 and the value of x when y is negative 5. So start writing the equation. Y is 2x minus 3. Then substitute x with 4. 2 times 4 minus 3. 2 times 4 is 8 minus 3 is 5. So y is equal to 5. Then b, we should write the equation first. Y is 2x minus 3. Then substitute y with negative 5. Negative 5 is equal to 2x minus 3. Negative 5 plus 3, because we move it to the left hand side, is equal to 2x. Negative 5 plus 3 is negative 2, is equal to 2x. So x is negative 2 divided by 2. The answer is negative 1. Next, the equation of a function is y is equal to negative 1 out of 3x minus 2 out of 5. Find a, the value of y when x is 0, and the value of x when y is negative 2 out of 3. So we write the equation first. Y is equal to negative 1 out of 3x minus 2 out of 5. Then substitute x with 0. So negative 1 out of 3 times 0 minus 2 out of 5. Negative 1 out of 3 times 0 is 0. 0 minus 2 out of 5. So the answer y is negative 2 out of 5. Next, B. We will write the equation first. Y is equal to negative 1 out of 3x minus 2 out of 5. Then substitute y with negative 2 out of 3. On the right hand side, we'll make it into like fraction. This is 3, this is 5. So make it out of 15. 3 times how many equals to 15? 3 times 5. Do the same to the top number. So negative 1x times 5 is negative 5x. 5 times how many equals to 15? 5 times 3. Do the same to the top. Negative 2 times 3 is negative 6. Then do the cross multiplying. 3, open bracket, negative 5x minus 6 is equal to negative 2 times 15. Then expand. 3 times negative 5 is negative 15x. 3 times negative 6 is negative 18. Negative 2 times 15 is negative 30. So 15x is equal to negative 30 plus 18. Negative 15x is equal to negative 12. Negative 15 times x is equal to negative 12. So x is negative 12 divided by negative 15. So the answer is 4 out of 5. Drawing graph of linear function. On a sheet of graph paper using a scale of 2 cm to represent 1 unit on the x-axis and 1 cm to represent 1 unit on the y-axis, draw the graph of the function y is equal to 2x for values of x from 0 to 4. Remember, y is the output, x is the input. So draw the table first. X and y. Remember, x is the input from 0 to 4. 0, 1, 2, 3, 4. Y is the output. Y is equal to 2x. So, if x is 0, so y is 2x. 2 times 0 is 0. Next, if x is 1. So y is 2x. 2 times 1 is 2. When x is 2, so y is 2x. 2 times 2 is 4. When x is 3, so y is 2x. 2 times 3 is 6. When x is 4, so y is 2x. 2 times 4 is 8. So after that, we'll draw the graph. The horizontal line is the x-axis, while the vertical line is the y-axis. Using a scale of 2 cm to represent 1 unit on the x-axis. So this is 1, this is 2, this is 3, and so on. And after that, 1 cm to represent 1 unit on the y-axis. So this is 1, 2, 3, 4, and so on. And after that, here, 0, 0, 1, 2, 2, 4, then 3, 6. So the point 3p lies on the graph in part A, then find the value of p. The value of p, the x is 3 and y is p. So when x is 3, so y is 6, or p is equal to 6. So here is the graph. The point 3p lies on the graph, so the value of p is equal to 6. Equation of straight line. The equation of a straight line is usually written this way. Y is equal to mx plus c. M is the slope of gradient, and c is the y value when x is equal to 0, where the constant m is the gradient of the line and the constant c is the y-intercept. So, to get the gradient, m is how far up out of how far down. So, for example, this graph, the gradient is, we will choose these 2 points. How far up is 1, 2, 3, 4. Out of how far down? 1, 2. 4 divided by 2 is equal to 2. C is the y-intercept. When x is 0, y is equal to 1. So the equation of the line is y is equal to mx plus c. Y is equal to, the gradient is 2x plus c, 1. The equation of a straight line is y is equal to 2x minus 1. State its gradient and y-intercept. The gradient is 2, while the y-intercept is negative 1. So the equation of the straight line is y is equal to mx plus c. Y is equal to 2x plus negative 1. So y is equal to 2x minus 1. A line has gradient negative 3 and y-intercept 4. State its equation. The gradient is negative 3 and the y-intercept is 4. Y is equal to mx plus c. So y is equal to negative 3x plus 4. State the gradient and y-intercept of each of the following lines. Remember, y is equal to mx plus c. Y is 4x minus 3. So the gradient is 4 and the y-intercept is negative 3. Y is equal to negative x plus 7. The gradient is negative x. So the gradient is negative 1, while y-intercept is 7. Y is equal to x plus 5 out of 2. The gradient is 1. And the y-intercept is 5 out of 2. Y is equal to 7.16 minus 0.5x. So the gradient is negative 0.5 and y-intercept is 7.16. Y is equal to 6x. So the gradient is 6 and the y-intercept is 0. And the last one, y is 6. So the gradient is 0 and y-intercept is 6. State the equation of each of the following lines given its gradient and y-intercept. Remember, y is mx plus c. M is the gradient, c is the y-intercept. The gradient is 3 and y-intercept is 5. Y is mx plus c. So y is 3x plus 5. Next, gradient is 7. Y-intercept is negative 2. So y is mx plus c. So negative 7x minus 2. Next, gradient is 1. Y-intercept is negative 2 out of 3. Y is mx plus c. The gradient is 1. So y is 1x minus 2 out of 3. You just write it as y is x minus 2 out of 3. Next, gradient is negative 1. Y-intercept is 7.69. So, y is 7.69 minus x. Gradient 1 out of 2, y-intercept is 0. So, y is negative 1 out of 2x. Gradient is 0, y-intercept is negative 1 out of 2. So y is negative 1 out of 2. Given the values of m and c, state the equation of a line whose gradient is 3 and whose y-intercept is 2. So gradient is 3, m is 3, y-intercept c is 2. Substitute these values in y is equal to mx plus c. The gradient is 3, so 3x, y-intercept is 2, so plus 2. A line cuts the y-axis at 0, 5 and has a gradient of 4. State its equation. Since the line cuts the y-axis at 0, 5, its y-intercept is 5. So m is 4 and c is 5. Remember, m is the gradient, c is the y-intercept. Then substitute these values in y is equal to mx plus c. So 4x plus 5. Determine the equation of the line passing through the point 3, 5 with a gradient of 2. We calculate the value of c by substituting the value of m and the coordinates in the equation y is equal to mx plus c. So, substitute m, gradient is 2, and x is 3, and y is 5. So, y is equal to mx plus c. Y is 5 is equal to 2x plus c. X is 3. So 5 is equal to 2 times 3 plus c. 5 is equal to 6 plus c. So c is equal to 5 minus 6. So the answer C is negative 1. So y is equal to mx plus c. We got c is negative 1. So the gradient is 2. So 2x plus negative 1. So the answer is 2x minus 1. So the equation of the line is y is equal to 2x minus 1. Calculation of gradient straight line. The gradient of a straight line is a measure of its steepness. The equation of a straight line is y is mx plus c, where m is the gradient and c is the intercept, where the line crosses the y-axis. To get the gradient m is change in y out of change in x. Change in y means how far up. 1, 2, 3. Change in x means how far along. 1, 2, 3, 4, 5. So the gradient is 3 out of 5. The gradient of a line can be positive or negative. This is negative gradient going down, and here is the positive gradient going up. So remember, the sign of gradient of straight line are if a line slopes upward from left to right, its gradient is positive. But if a line slopes downwards from left to right, its gradient is negative. Find the gradient of each of the following lines. So remember, to get the gradient is change in y out of change in x, or how far up out of how far along. So for example, in equation 8, to get the gradient is we must choose 2 points on the line with coordinates that can be read easily. So for example, this is 7 and 4. To get the gradient is how far up out of how far along. The slopes upward, going up. So how far up is 1, 2, 3. So 3 out of how far along? 1. 3 divided by 1 is 3. So the gradient is positive 3. Or the other way, for example, I choose another 2 points, 7 and 1. The slopes upward, so the m, the change in y, or the vertical change is 1, 2, 3, 4, 5, 6. 6 out of how far along? 1, 2. 6 divided by 2 is 3. So remember, if the slopes upward, so its gradient is positive. Next, question B. Take a look here. The line slopes downwards from left to right. So the gradient is negative. So let's choose the 2 points on the line with coordinate that can be read easily. For example, 6 and 3. So how far up? Because this is slope downward. So 1, 2, 3. Negative 3 out of how far along? 1. Negative 3 divided by 1 is negative 3. Or another way to get the gradient, we find another 2 points. Let's say 6 and 4. So change in y is 1, 2, 3, 4, 5, 6. Because it's going down, so negative 6 out of how far along? 1, 2. Negative 6 divided by 2 is negative 3. So don't forget, if a line slopes downward from left to right, its gradient is negative. Calculate the gradient of each of the following lines. Remember, to get the gradient, it's vertical change out of horizontal change, or rise out of step, or how far up out of how far along. And if a line slopes upwards, so its gradient is positive. And if a line slopes downwards, its gradient is negative. So in question A, how far up? So the line slopes upward. So 1, 2, 3, 4, 5, 6 out of 1, 2, 3, 4, 5, 6. 6 out of 6. So the gradient is 1. B, the line slopes upwards. So the gradient is positive. So the vertical change is 1, 2, 3, 4, 5, 6. While the horizontal change is 1, 2, 3. So the answer is 6 divided by 3 is 2. See? The line slopes upwards. So the gradient is positive. So the vertical change is 1, 2, 3, 4, 5, 6. Out of the horizontal change is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 out of 12. Don't forget to simplify, is 1 out of 2. Next, D, the line slopes downwards. So the gradient is negative. So the vertical change is 1, 2, 3, 4, 5, 6. Negative 6 out of 1, 2. Negative 6 divided by 2 is negative 3. Find y-intercepts. The y-intercept is the point at which the graph crosses the y-axis. At this point, the x-coordinate is 0. So for example, This graph crosses the y-axis at 0, -1. So the y-intercept is -1. And here is the second. The graph crosses the y-axis at 0, 6. So the y-intercept is 6. And the last one, this graph crosses the y-axis at 0, 0. So the y-intercept is 0. Find x-intercept. The x-intercept is the point at which the graph crosses the x-axis. At this point, the y-coordinate is 0. So for example, this graph crosses the x-axis at 5, 0. So the x-intercept is 5. And this one, the graph crosses the x-axis at -9, 0. So the x-intercept is -9. Y is equal to mx plus c. How do you find m and c? To get m, or the gradient, is change in y out of change in x. How to get c? C is easy. Just see where the line crosses the y-axis. So look at this graph. This line slopes upward from left to right. So its gradient is positive. So the gradient is, you may take two coordinates here. So for example, this one and here. So change in y, or how far up? 1, 2, +2, out of change in y, or how far along? 1. 2 out of 1 is 2. Y is equal to mx plus c. The gradient is 2. So 2x, and then we will find the y-intercepts. The y-intercepts is 1. So y is equal to 2x plus 1. Given 2 points of the line, determine the equation of the line that passes through the points 2, 1 and 4, 7. Look at the line. The line slopes upwards, going up. So its gradient is positive. To get the gradient is how far up out of how far along. So 1, 2, 3, 4, 5, 6, +6 out of 1, 2. 6 divided by 2 is 3. Y is equal to mx plus c. Choose either of the points. For example, 2, 1. So y is 1 is equal to, the gradient is 3 times x, 2. 3 times 2 plus c. 1 is equal to 6 plus c. So c is 1 minus 6. C is equal to -5. Y is equal to mx plus c. The gradient is 3. So 3x plus c is -5. 3x plus -5. So y is equal to 3x minus 5. If we had instead of using the point 4, 7 and the same gradient 3, we would have obtained the same equation. Y is equal to 3x minus 5. gradient of horizontal line. Look at this graph. There are points A, B, C, and D. Write down the coordinates of B and D. B is -1, 2. D is 4, 2. In the line segment AC, vertical change is 0 and horizontal change is 1, 2, 3. So to get the gradient is 0 divided by 3 is equal to 0. In the line segment BC, the vertical change is 0 and horizontal change is 1, 2, 3, 4, 5. So the gradient is 0 divided by 5 is equal to 0. What can you conclude about the gradient of a horizontal line? The gradient of a horizontal line is 0. Horizontal lines have no steepness at all, because any calculation of the slope of horizontal lines means dividing 0 by another number. The slope of a horizontal line is always 0. So remember, a horizontal line has no slope. Its gradient is 0. Now look at this graph. Remember that the gradient of a horizontal line is 0. The horizontal line has no slope. And then, how to write the equation? The horizontal line graphed above has a y-intercept of 0, -2, and no x-intercept. So the equation is y is equal to -2. Gradient of vertical line. Now, remember how to get the gradient. This line going up. The slope upwards. Remember, if upwards, so the gradient is positive. To get the gradient is how far up out of how far along. Let's say we choose this coordinate. How far up is 2, positive 2, out of how far along is 1. 2 divided by 1 is equal to 2. Then how to write the equation? Y is equal to mx plus c. The gradient is 2, 2x, plus the y-intercept is 1. So y is equal to 2x plus 1. Next, this one. There are 4 points, P, Q, R, and S. Write down the coordinates of Q and S. Q is 3, 2. S is 3, -3. In the line segment PR, the vertical change is 1, 2, 3, 4. And horizontal change is 0. So its gradient is 4 divided by 0. The answer is undefined. In the line segment QS, vertical change is 1, 2, 3, 4, 5. And horizontal change is 0. So its gradient is 5 divided by 0. It's undefined. What can you conclude about the gradient of a vertical line? The gradient of a vertical line is undefined. Why the gradient of a vertical line is undefined? Because the horizontal change is always 0. In other words, a vertical line is so steep that we cannot specify a value for its gradient. Now look at this example. X-intercept is 6, 0. So the equation of this straight line is x is equal to 6. Now remember that the gradient of a vertical line is undefined. Look at this straight line. Is the vertical line going up on one end? Well, yes, kind of. So maybe the slope will be positive. Is the vertical line going down on the other end? Well, again, kind of. So maybe the slope will be negative. But is there any number that is both positive and negative? No. So vertical lines have no slope. The concept of slope simply doesn't work for vertical lines. The slope of a vertical line doesn't exist. We cannot divide by 0, right? So for example, if I choose this coordinate, to get the gradient is how far up out of how far along. How far up is 1, 2, 3, 4. How far along is 0. We cannot divide by 0, which is of course why the slope value is undefined. Now, go to the next question. Remember that the gradient of a vertical line is undefined. So, the vertical line graph above has an x-intercept, 3, 0, and no y-intercept. So, the equation is x is equal to 3. What is the equation of a vertical line? So this one is x is equal to 1.5. Remember that the gradient of a vertical line is undefined. Draw the graph with the equation y is equal to 2x plus 3. So first, we should draw the table of values for the equation y is equal to 2x plus 3. So this is x, this is y. X is the input, while y is the output. Y is equal to 2x plus 3. So you may write any x. For example, negative 2, negative 1, 0, 1, 2. If x is negative 2, find y. Y is 2x plus 3. So 2 times negative 2 plus 3. Negative 4 plus 3 is negative 1. If x is negative 1, y is 2x plus 3. So 2 times negative 1 plus 3. Negative 2 plus 3 is 1. If x is 0, y is 2x plus 3. So 2 times 0 plus 3. 2 times 0 is 0 plus 3 is 3. If x is 1, so y is equal to 2 times 1 plus 3. is equal to 5. And if x is 2, so y is 2, x plus 3, 2 times 2 plus 3 is equal to 7. Next, we plot these points on graph paper using a suitable scale. The plotted points are joined to form a straight line. So this one is -2, -1. -1, 1. 0, 3, 1, 5, 2, 7, 3, 9. So don't forget to join all the points. Draw the straight line, and the line may be extended to any desired length. Determine the equation of each of the following lines. Equation A, the line slopes upwards. It's going up. So its gradient is positive. To get the gradient is how far up out of how far along. Let's say we choose this coordinate. How far up is 1, 2, 3. Positive 3 divided by how far along? 1, 2, 3. 3 divided by 3 is 1. Y is equal to mx plus c. The gradient is 1. So 1x, c is the y-intercept. Y-intercept is positive 2. So y is equal to 1x plus 2. Or we just write it as y is equal to x plus 2. Question B. The line slopes upwards, so the gradient is positive. For example, we choose this coordinate. How far up is 1, 2, 3, 4, positive 4, divided by how far along? 1, 2. 4 divided by 2 is 2. Y is equal to mx plus c. The gradient is 2. So 2x plus c is the y-intercept. Y-intercept is -1. So 2x plus -1. So y is equal to 2x minus 1. Application of linear graphs in real-world context. Linear functions and graphs are used in many daily situations. In this section, we will examine how linear functions can be used to model some real-world situations. So this is the taxi fare. The flat-down fare of taxi is $3. So this is the fixed amount. Question A. Given that the passenger is charged 50 cents for each kilometer the taxi travels, find the amount of money the passenger has to pay if the taxi covers a distance of 2 km, 6 km, and 10 km. Question B. Given that $Y represents the amount of the passenger has to pay if the taxi travels X km, copy and complete the table. So here, a linear function can be used to model a taxi fare with a fixed variable cost per km travel. So remember, x is the input. The inputs are 2 km, 6, and 10. Y is the output. So to get the output, is Y is equal to $3 plus 50 cents times x. if x is 2. So 3 plus 50 cents times 2. The answer is $4. If x is 6. So 3 plus 50 cents times 6. The answer is $6. And then if x is 10 km. So 3 plus 50 cents times 10 is equal to 8. So the cost for 2 km is $4. The cost for 6 km is $6. And the cost for 10 km is $8. On a sheet of graph paper, using a scale of 1 cm to represent 2 km on the horizontal axis and 1 cm to represent $1 on the vertical axis, plot the pairs of values x, y. Before we already get the value of x and y, then we will draw the graph. So look over here, this is the x and y axis. For the x-axis, using a scale of 1 cm to represent 2 km. This is 1 cm, 1 cm, 1 cm. So this is 2 km, 4 km, 6 km, 8 and 10 km. And then for the y-axis, 1 cm to represent $1. This is 1 cm, 1 cm, 1 cm. $1, $2, $3 and so on. 2, 4. Here is 2, 4, 6, 6, 10, 8. Question D. Write down the equation of the straight line. The line slopes upward, so the gradient is positive. To get the gradient is how far up out of how far along. So for example, we choose this coordinate. How far up is? 1, 2. 2 out of how far along? 1, 2. Remember, for the horizontal axis, 1 cm to represent 2 km. So this is 2. How far along is 2 times 2 is equal to 4. So the gradient is 2 out of 4 or 1 out of 2, 1/2. So y is equal to mx plus c. The gradient is 1/2 or 0.5. So y is equal to 0.5x plus c. C is the y-intercept. Y-intercept is 3. So the equation is y is equal to 0.5x plus 3. Question E. How much does a passenger have to pay for a taxi ride of 8 km and 17 km? There are 3 methods. The first, the cost for 8 km is $3 plus 8 times 50 cents is equal to $7. Method 2. Substitute x into y is equal to 0.5x plus 3. So 0.5 times 8 plus 3 is equal to 7. The third from the graph. When x is equal to 8, find the value of y. Y is equal to 7. So the cost for 8 km is $7. Next, how about 17 km? There are two methods. The first, the cost for 17 km is $3 plus 17 times 50 cents. Is equal to $11.50. The second method, we will use y is equal to 0.5x plus 3. Substitute x with 17. So 0.5 times 17 plus 3 is equal to 11.5. So the cost for 17 km is $11.50. Distance time graph. The travel graph shows a journey taken by a cyclist. He started his 50 km journey at 8 a.m. At 9 a.m., he spent half an hour replacing a punctured tire. He then continued his journey and reached his destination at 11:30 a.m. Question A. How far did the cyclist travel before his bicycle tire was punctured? The answer is 20 km. Question B. Find the gradient of each the following line segments, stating clearly what each gradient represents, OA, AB, and BC. The gradient of the line in distance time graph is a measure of the speed of the object. In this context, the gradient has a unit of measure. To get the gradient is how far up, out of, how far along, OA. How far up? 10 km, 20 km. How far along? From 8 o'clock to 9 o'clock, 1 hour. So the answer is 20 km per hour. This means that the average speed of the cyclist from O to A was 20 km per hour. Gradient of AB is 0. This means that the average speed of the cyclist from A to B was 0 km per hour. Why? Because he was stationary. And the last, the gradient of BC. How far up? 10, 20, 30 km. Out of, how far along? From 9:30 to 11:30. 2 hours. So the answer is 15 km per hour. This means that the average speed of the cyclist from B to C was 15 km per hour. An electrician charges an initial fee of $35 for attending a house call. If he charges $15 for every hour spent on the job, find the amount of money the house owner needs to pay if he spent 1 hour, 2 hours, 3 hours, and 4 hours on the job. So over here, this is initial fee is $35, so 35 plus 15x. So for 1 hour, so 35 plus 15 times 1 is equal to $50. 2 hours, so 35 plus 15 times 2 is equal to $65. 3 hours, so 35 plus 15 times 3 is equal to $80. And the last one, 4 hours, so 35 plus 15 times 4 is equal to $95. Question B. Given that $y represents the charges the house owner has to pay and x is the number of hours the electrician spent on the job, copy and complete the table. X is 0, so y is 35. Remember, x is the input. So 0 hour, 1 hour, 2 hours, 3 hours, and 4 hours. Y is the output. To get the output is 35 plus 15x. So if x is 0, so y is 35. X is 1, y is 50. X is 2, y is 65. X is 3, y is 80. X is 4, y is 95. Question C. On a sheet of graph paper, using a scale of 2 cm to represent 1 hour on the horizontal axis and 1 cm to represent $10 on the vertical axis, plot the pairs of values x, y. So here is the graph. Write the scale carefully for the x-axis 2 cm to represent 1 hour. So this is 2 cm, 2 cm, 2 cm. 1 hour, 2 hours, 3 hours, 4 hours. And then for the y-axis, 1 cm to represent $10. This is 1 cm, 1 cm, 1 cm. $10, $20, $30, $40. And then join all the points, draw the straight line, and don't forget to write the equation. Y is equal to 15x plus 35. Question D. Use the graph to find the amount of money he charged the house owner if he spent 2.5 hours on the job. You may use a ruler. So this is 2.5 hours. From the graph, amount of money charged if he spent 2.5 hours on the job is $72.50. And then the last one. Find the amount of hours the electrician spent on the job if he charges $90 on the job. $90 is here. You may use a ruler. So from the graph, the number of hours that the electrician spent on the job is 3.6 plus minus 0.1 hours. On a sheet of graph paper, using a scale of 1 cm to represent 1 unit on the x-axis and 1 cm to represent 2 units on the y-axis, draw the graph of each of the volume functions for values of x from -6 to 6. So the first x is equal to 1. So x is equal to 1, this is the vertical line. Then the second, x plus 5 is equal to 0. So the value of x is equal to -5. So this is also the vertical line. The third, y is equal to -1/2 x minus 2. So first, we should draw the table. X is the input, y is the output. The x is from -6 to 6. So the input are -6, 0, and 6. Then, to get y is equal to -1/2 x minus 2. -1/2 times -6 is equal to 3. 3 minus 2 is equal to 1. How about if x is 0? So y is equal to -1/2 x minus 2. -1/2 times 0 is 0. 0 minus 2 is equal to -2. And then if x is 6, y is equal to -1/2 x minus 2. -1/2 times 6 is equal to -3. -3 minus 2 is equal to -5. And then the fourth, y is equal to 3x minus 7. Draw the table first. X is the input, y is the output. X is -1, 0, and 6. When x is -6, so y is equal to 3x minus 7. 3 times -6 is equal to -18. -18 minus 7 is equal to -25. When x is 0, so y is equal to 3x minus 7. 3 times 0 is 0. 0 minus 7 is -7. And then when x is 6, so y is 3x minus 7. 3 times 6 is 18. 18 minus 7 is 11. After that, we will draw the graph. Here is the graph. This is the x-axis. And then, here is the y-axis. Using a scale of 1 cm to represent 1 unit on the x-axis, and 1 cm to represent 2 units on the y-axis. So this is for the x-axis 1, 2, 3, 4, 5, 6. For the y-axis, this is 0, 2, 4, 6, 8, 10, 12. The first x is 1, the vertical line. The second, x plus 5 is equal to 0. X is -5, the vertical line. And then, y is equal to -1/2 x minus 2. This one. -6, 1. Here. And then, 0, -2, 6, -5. And then the last function, y is 3x minus 7 is here. So this is negative 6, negative 25 is here. And then 0, negative 7 is here. Then 6, 11. Question B, name the figure formed for the lines drawn in A. Here's the graph. So the shape of the figure formed by the line is a trapezium. Here is the trapezium. This is the pair of parallel lines. Let's say this is A, this is B, and then this is the height of the trapezium. B. Find the area bounded by the lines drawn in A. So, to get the area of a trapezium is A plus B divided by 2 times the height of the trapezium. A is 1.5. This is A. While B is 22.5 divided by 2 times the height of the trapezium is 6. 1, 2, 3, 4, 5, 6. So the answer is 72 square units. Billy, the president of publicity of a school, wants to print newsletters for a school event. He goes to a printing company to find out the cost of printing newsletters. Billy was told that every 15 newsletters printed, he has to pay N dollars. He was given the following graph showing the cost $T to print N newsletters. Question A, copy and complete the table. So this is the number of newsletters, N, and then here is the cost, or C dollars. So when N is 50, so C is equal to $350. When N is 100, so the C is $200. When N is 150, so the C is $250. When N is 200, so C is $300. Question B. Billy was puzzled that the graph shows he has to pay M dollar even though he has not printed any newsletter. What's the value of M? From the graph, the value of M is 100. Explain why he has to pay M dollar even though newsletter is printed. He has to pay M dollar for the operation cost of printing the newsletter. Question C. Find the amount of money Billy has to pay for printing 75 newsletters. From the graph, the amount of money Billy has to pay is about $175. If he is given $255 by school, state the maximum number of newsletters he can ask the company to print. From the graph, The maximum number of newsletters he can ask the company to print is about 160. Using a scale of 1 cm to represent 1 unit, draw a horizontal x-axis for values x from -5 to 5. Using a scale of 1 cm to represent 2 units, draw a vertical y-axis for values of y from -8 to 14. Draw the graph of each of the following functions for values of x from -5 to 5. So the first function, y, is 2x plus 3. X is the input, y is the output. So x is -5, 0, 5. When x is -5, so y is 2 times -5 plus 3. 2 times -5 is -10. -10 plus 3 is equal to -7. When x is 0, so y is 2 times 0 plus 3. 2 times 0 is 0. 0 plus 3 is 3. When x is 5, so y is 2 times 5 plus 3. 2 times 5 is 10. 10 plus 3 is 13. Then the second function, y, is 6 minus x. X is the input, y is the output. X is -5, 0, 5. When x is -5, so y is 6 minus x. 6 minus -5. So 6 plus 5 is equal to 11. When x is 0, so y is 6 minus 0 is equal to 6. When x is 5, so y is 6 minus 5 is equal to 1. After that, we will draw the graph. Here is the graph. The first function, y is 2x plus 3. This is -5, -7, 0, 3, 5, 13. The second function, y is 6 minus x. This is -5, 11, 0, 6, 5, 1. The point A0 lies on y is 2x plus 3. Write down the value of a. The value of a is -1.5. Question C. The point 4P lies on y is 6 minus x. Write down the value of b. The value of b is 2. Question D. The point HK lies on both y is 2x plus 3 and y is 6 minus x. Write down the values of h and k. H is 1, k is 5.
That's all from me. Thank you for watching. Don't forget to like and subscribe.